Little technical difficulty. For some reason, when I went live earlier, I had a little bit of an issue. Anyway, we're ready to do some experiments, so let's go, baby. Here we go. Let's get these flasks filled with some water. Get the vortex going. We're going to add some universal indicator to both flasks. Universal indicator is also known as rainbow indicator. Rainbow indicator displays different color at different pH values. Hello there, Simon. pH just tells you how acidic or basic something is. Sorry if you were in the other live stream that didn't end up working out so well. Something goofy happened, so I just restarted it. Yeah, we're adding a little universal indicator to both of these flasks here. Glad to have you along there, Tommy. So you can see that color looks kind of like oranges to me. Maybe it looks the same to you. If you match that with the color chart here, this is showing you the different colors that will be displayed and the respective pH values for each color. So yeah, it looks to me, let's see here. Let's shine a little more light on that like that so we can see it just a little bit better. It looks like about a pH of 5 to me. And that just tells you how acidic or basic something is. A pH of 5 is slightly acidic. So a pH of 7, that's going to be neutral. Below 7 is going to be acidic. Above 7 is going to be basic. All right, now I'm going to add some base or alkali to the flask on the left. Let's just do 1 drop. See what happens. And over here on the right, I'm going to add 1 drop of acid. This is hydrochloric acid, the same acid that's found in your stomach. We see a big difference in color shift, don't we? Absolutely we do. We see red over here on the right, pH of 3, which is acidic. We see a pH of 10, turn violet over here on the left, and that indicates alkalinity. Beautiful stuff. So now what I'm going to do is I'm going to turn both of these off so it's no longer spinning. And now I'm going to add a bunch of hydrochloric acid. Let's do 5 drops. 5 drops of hydrochloric acid over there on the left and 5 drops of sodium hydroxide. That's a base over here on the right. Let's just watch what happens here. Hello there, Jada. Jada, nice to have you along. Hey there, Thomas. Hello there, the commenter. That's pretty cool, isn't it? Thank you there, Jada. Hey, Knighton, you liking the colors there? So what is this? Let's talk about what it is. Hello, Agnostic. Hello, Sabrina. Hey there, Vi. Agape, hello. So what I've got in here is in both flasks, I have some universal indicator. Universal indicator is also known as rainbow indicator. It just tells you the acidity or basicity of the fluid. We use a term for acidity or basicity. We call that pH. And you can see your pH scale here. It's going to run from 3 to 10. It actually runs further than that, but these are the only colors that this displays from 3 to 10. Thank you there, the commenter. And then you can see here, this is red. That's a pH of 3. Over here, it's violet. That's a pH of 10. 10 is very basic. 3 is very acidic. And over here, we actually see 2 different pHs at the same time. Kind of cool here. Let's add a little bit more acid over here on the right. So I'm adding hydrochloric acid. It's the same acid that's found in your stomach. Let's see what happens. Hello there, Origami. Thank you there, Fantatui. Fantatui. It does look like a full spectrum camera. Hello there, United States. What's going on there, Brick Lab? Hey there, Kazi. Thanks for the sub there. Is base heavier than acid? It depends, right? I do think the stuff I'm using is a little more acidic. Thank you there, Agnostic. Hey, Peiko. Thank you there, Alex. Okay, let's mix it up now, all right? So I'm going to turn the stir bars on. Let's do the one on the right first. I'm going to turn that one on over here. Can you have a drink? I think I might ruin your afternoon or your evening if you had a drink. One of the dyes that's contained in here, thank you there, Psycho, I appreciate it. One of the dyes contained in here is a laxative. Hey there, Psycho. Okay, I'm going to add some base. It does look drinkable, but it isn't, I can assure you. I'm going to add some base over here on the right. You can see the color change grow to violet. And then we're going to get this spinning over here on the left. Hello there, Muhammad. And I'm going to add some base over here on the left. Let's just add one little drop. Every once in a while, I can get like a rainbow effect going on where you see all the colors of the rainbow in the flask. Charlemagne wants it green. I'm going to go for that, Charlemagne. Sorry, I know I'm not saying your name correctly. I'm going to add another drop of base. Look at there. I think we might... Look, we got the rainbow over there on the left. That was cool. There's your green. It's kind of yellow-green. Often sure, I could make -1 pH. However, it would all just look red, so you can't really tell that. Kazi, I appreciate you being on board for a long time. Thank you. Hello there, Coconut. Hello there, Brick Lab. Okay, thank you there, Coconut. Thank you there, folks. Okay, I'm going to add another drop of base. So right now we're at like a pH of 6 or 7. Watch what happens when I add a drop of base. Sodium hydroxide base. Look at there, it goes to violet. So we've got an excess of base present. Now I'm going to start adding acid to both of these. This is hydrochloric acid. Thank you there, the commenter. We're going to add hydrochloric acid. It's the same acid that's found in your stomach, except this stuff is like 100 to 1,000 times more concentrated. So in goes 1 drop of acid over there on the left. Thank you there, 6. Second drop of acid over there on the left. We got a little rainbow flash. Come on now. I think that's kind of cool. I want some color changing drinks too. Make it light blue, says Origami. I'll try that. Let's try it over here on the right. I'm going to add 1 drop of acid over there on the right. Hydrochloric acid, same acid's found in your stomach. How you doing there, Bunny? All right, we're going to do another drop of acid over there on the right. I'm trying, Vortex. pH 8 is tough to get. So, Adriana, what's going on here is we have in these flasks some universal indicators. Just a mixture of dyes that shows different colors depending upon pH. Here's your pH scale. And pH just tells you how acidic or basic something is. Thank you there, Bunny. I appreciate it. And you can just read off the chart. You can see if we're at 7, we're neutral. If we're below 7, we're acidic. If we're above 7, we're basic. Vortex, I'm having trouble getting it to... why does we say base instead of alkali, Clover? Because here in the United States, we use base and alkali synonymously. So forgive me, I am going to use base and alkali synonymously. That's just the way that we're used to doing it. Now notice, over here we're at pH 7. Vortex is asking me, by the way, Vortex, come on now. Come on, Vortex. This is all for you right here, but I'm also going to try to get it aqua for you. I'm at pH 7. I've got to get it to aqua color, pH 8. To do that, I've got to add base. But I got to add just a little bit because it's just slightly basic. So the way I do that, watch this up here. I'm going to take my dropper that's got the base in it, and I'm going to just touch the dropper bottle to the side of the flask right here. And I'm just going to push a little bit. Whoop. There it goes, right down the side. And I added too much because it's so stinking hard to do. My pH scale isn't going happy with me. 3 or 4, we got that next. I'm going to try to add a little bit more acid here. We're going to try to add just a sniff of acid here. I'm going to just put that little touch right there. Watch when that drip goes in right here. I'm going to just tilt it to make it go in. That should maybe give us... No, I'm going to try another just slight drip. Is it going to go aqua? Is it going to go aqua? I think I got your aqua there, buddy. Come on now. I got it, Vortex. I got your aqua for you. Why is water pH 7? Water's pH 7. Wow, why is water pH 7? It's okay. So I got to tell you the definition of pH in order to get you there. Let me add a drop of... base over here on the right. So water's pH 7 because pH is actually, it's too much math, man. It's just too much math, but I'll show you here. I'm going to lose a lot of people here with this. It's basically this. The product of protons and hydroxide in a solution has to be 10 to the negative 14, which is a really tiny number. For those to be neutral, for hydroxide and for protons to be neutral, they've got to be the same, right? The protons are acidic, the hydroxide, that's basic. And so for it to be a neutral solution, those two have to be equal. And the only way for them to be equal and for their product to be 10 to the negative 14 is for both of them to be 10 to the negative 7. And that negative 7 that you see has to do with the pH 7. So the pH is basically the negative power of 7 of the proton concentration. I know, that's a lot of technical stuff. Let's just do some goofy science here for a bit. Can you drink a base? Sure you can. You can sure drink a base. You're welcome there, Kazi. I don't know if you follow that or not, but it's a little hard to do without writing on the chalkboard. What happens if you mix them? What a great question. Let's do it. Come on now, let's do it. Let's get pH 10 over here, and we got pH 1 over here. So what do you think will happen if I mix them? Let's find out. I'm going to put this beaker right here, and what I'm going to do is I'm going to get a little bit of each fluid. Let's get a little bit of each fluid, and we're going to stick them in here. So I'm going to mix the red fluid and the purple fluid together. And let's see what we get if I do that. Sorry, I'm not reading the comments just this second because I'm focusing on the experiment at hand. Let's give that a swirl. It looks like it's a little more basic than it is acidic, so I'm going to just get one more squirt of acid here. There we go. And that's what I would expect to see. If you mix together the acid and base, they're going to neutralize each other if you get equals amounts. It looks like the base is just a little bit more concentrated. But you can see, yeah, if I mix them together, so let me show you here. If I mix together the pH, it's upside down. The pH 7, which is red, the pH 3, which is red, and the pH 10, which is violet, they neutralize each other. That's why I got green when I mixed these two together. Great question. No, you don't want to drink it. Trust me. One of the dyes that's in this mixture is a laxative. So drop the emoji in the chat that would describe what would happen if we drank this. Come on now. Thank you there, Simulated. Yes, you can drink acid. We drink acid all the time. So if you've ever drank lemonade, lemonade contains citric acid. There they are. I'm seeing it. AP and Michael and Izzy and Wasn't Meh and Laugh. I'm seeing it all. Mr. Giggles, you all got it. Let's add a little bit of base over here on the right. And let's add a little bit of acid over here on the left. See if we can get the rainbow going on. I'm going to just slow. Oh, there it was. We got a little rainbow flash over there on the left. I love it. Really cool, man. Really cool. Jay and Connor, I'm seeing you, man. This commenter, indeed. Fire Chai says mix 7 and 8. Man, it's hard to get those two. FIFA Boy, you got it. Lucas, you can drink acid, buddy. You certainly can. I'm adding acid to both of these, like, citric acid, for example. That's in lemon juice, lime juice, orange juice. So we drink acid all the time. Let's make them random colors, then predict the color, and check the results. Hey there, games. Thank you for the sub, Harper. Let's make them random colors, then predict the color, and check the results. I'm not sure what you mean by that. I apologize. Games, of course I remember you. Let's make them random. Yeah, Kazi, I'm not 100% sure what your request is. You got to be a little more specific for me. I'm a little bit dense. I apologize. Come on, Ghost. Come on, man. I don't want YouTube to ban me. Oh. Thabisco is what I'm guessing it was. Thank you, AP Foo, for the subscription. I don't have any sodium metal with me here in my basement. However, I've done videos with some sodium metal and water. It's really interesting to watch for sure. Can I make one of them light blue? We're going to give it a shot. So this one over here, we want to make it light blue, which is pH 8. It's pH 10, so I've got to lower the pH, which means I need to add some acid. So here we go. I'm going to add some acid to this side over here on the right. Here we go, 1 drop. And that should lower the pH. Oh, it didn't. I added the base like an idiot. Let's try adding the acid now. The acid I'm adding is hydrochloric acid. That's the same acid that is found in your stomach. It's just that this stuff is like 100 to 1,000 times more concentrated. I'm going to add another drop of acid because that didn't look like that did a whole lot. But you can see the red growing in, yeah? You see that red color? Do I get it light blue? Come on, I think I did down here. It's kind of dark blue up here at the top. Yes, those are stir bar magnets for sure at the bottom. Here we go. I'm going to try to make this light blue. The way I do this, I'm at pH 9. I got to try to get it to pH 8. So I need to lower the pH just a little bit. So to do that, I need to add just a little bit of acid. 1 drop's going to be too much. So the way I try to do it is I'm going to go ahead and touch the dropper to the flask here. I'm going to push out just a tiny droplet. You might see it right there. Just a tiny little drop. And then we're going to let that tiny little drop go into the fluid. I'm going to tilt it so it goes in. There it goes. And let's see if we get it to light blue. You can see the acid go through. I overshot. Even that tiny little drop took us from pH 9 down to pH 7. I went a little too far. Hey, Soy, how's it going? You got it, Origin. What would happen if you drop acid and base? Let's find out. Okay, so we got neutral right here. Somebody said, what happens if you add acid and base? Here we go. I'm going to add a drop of each. 1 drop each into the green. It's at neutral. In goes a drop of each. You can see the red and the violet grow in. They're going to react with each other. If they perfectly neutralize each other, everything will end up neutral. If there's a little bit of excess base, we're going to end up on the blue or violet side. If there's a little bit of excess acid, that'll be orange, yellow, or red. And it looks like I have an excess of base. Let me add a drop of acid over here, see if I can't neutralize that. Let's fiddle around with this over here. I'm going to add 2 drops of base over here. It does look like midnight, Kazzy 8 or Kazzy B. All right, let me pop this in here, over here. A little bit of that. Oh, come on, give me a rainbow going on. I love it when we get the rainbow effect going on. Over there on the left, we got it. The elusive rainbow. Yeah, I'm using 20% by weight sodium hydroxide. Yep, that's what I'm using. It does look a little bit, we'll just say suspect over here. So let me add a drop of base over here to make the pH go up. Can you drink the neutral? Ask Dark Louise. Or Darkoise, forgive me, or Darkoise for mispronouncing your name. Can you drink the neutral? Well, technically it's going to be salt water because the reaction that's happening as I add either the sodium hydroxide base or the hydrochloric acid, when I add these two together, you're getting water and you're getting salt. So technically, if you perfectly balance them, which neither of these are, this has an excess of acid, this has an excess of base, but if I perfectly balance this, you should just have salt water. The issue is the indicator dye that I've added, it contains 4 different dyes, and one of them, unfortunately, is a laxative. It used to be actually the main ingredient in X-Lax. So, no, I wouldn't drink it when it was neutral for that reason. What is base? Here in the United States, we use that term synonymously with acid. Would you be able to drink pH 10? I wouldn't do it. Okay, over here, I'm going to add some acid to the side over here that's basic. Why is there no salt on the bottom of the jar? There's no salt because as the salt is formed, it dissolves in the fluid. So any salt that's formed, it just dissolves right in. So we're just making a lot of salt water is what we're making. Can you drink 8? I mean, you could drink any of these pHs if you wanted to. The question is what would it do to you, right? Are the different shapes of the vortices due to anything different? Yes, they are. Here, let's do this. Here's my magnet. So I'm going to go ahead and I'm going to take this magnet. I'm going to turn this off here. All right, let's see if I can get this out. So notice out it goes. Come on, baby. Come on, baby. Take this guy out. All right, there's my stir bar I was using, right? You can see it's got a certain size to it. I'm going to put a different stir bar in. That's smaller. Little tiny one. So compare the sizes. This is the size that was in there. This one's the size that I'm going to stick in. So in goes the little baby stir bar. And we'll get this guy going. Oh, man, that goes quick. And let's see what this one looks like. So the size of the vortex is going to depend on the size of the stir bar. It also depends on how fast the stir bar is spinning. So watch this one here. I'm going to turn this one up a little bit. So this one over here on the left, I'm turning this one up. Watch what happens to the size of the vortex. Gets bigger, doesn't it? So it depends on the size of the stir bar and the speed at which the stir bar is spinning. Come on now. I saw someone in the chat says pH 3 is 10,000 times more acidic than neutral. I'm loving it. The chemists have entered the chat for sure. I'm loving it. Great stuff. Could you drink that entire thing as a funny prank? I mean, you'd be the one that would be pranked, buddy. Thank you there, Carter. I appreciate it. Clover likes the purple. Well, let's make some purple there, Clover. There's a drop for you. It's got a funny little glare from this. I'm going to take this off just for a second. There's some interesting patterns going on over here. Can I make the tornado bigger? I'll try. Usually it knocks the stir bar out of orbit. Well, we're going to try it. I'm going to really turn this one up over here. Thank you there, David. I don't have any lithium SA. Oh, see, it knocked it out. The green and purple was beautiful. I agree. Would it burn if it's really acidic? Not too bad. I mean, this will burn. The stuff that I'm adding will. This is concentrated enough to, make my skin itch more than I want it to. Let's put it that way. I got to try something here. There we go. Okay. I'm going to add a drop of acid over here on the left. Can you control this reaction with temperature? It's not really sensitive to temperature all that much. I don't have any lithium SA. Where is... I missed it. Mix 3 and 10 together. You got it! Come on, we can do it right here. See it? We got 3 and 10. All right? We've got pH 3 and pH 10. We're going to mix them. So here we go. Let's check out what happens if we mix pH 3 and pH 10. I'm going to put this beaker right here. And we're going to mix pH 3 and pH 10. If you've been following along, you know what's going to happen. So I'm going to take these two droppers up here at the top. And I'm going to suck out some fluid into these two. And we're going to mix them together. And we're going to mix the two pHs together. And we're going to mix the two pHs together. I got to get enough so you can see the color that we end up with if I do this. Okay. If you've been following along, that makes sense to you. We mixed purple and red and made green. Now, how the heck did that happen? Does that make sense to you? It should. It should if you know what's going on with the pH scale. Put a thumbs up if you know why the purple and red made green. Put a thumbs down if you need an explanation. I'm doing pretty good there, Agent. We did it there for you, Skull Crash. I hope you enjoyed it. We mixed pH 3 and 10. pH 9 and 4, says the Flaming Duck. 9 and 4 are a little tough to get. Can I add the biggest stir bar? That's this one over here. So this is the biggest one I have. I'm going to turn both these off. Boy, look at that gorgeous color that's going on here. We got an interesting pattern. Look at the red down the middle. Look at that. You can see the red column from the acid going down the middle. Up here at the top, we got pH 10. Down here at the bottom, we got like pH 6. We got a lot of down thumbs. I'm going to have to do some explaining, okay? I'll do some explaining. But look over here at this stir bar. It's really big. Really big. So that's the biggest one I've got. Appa, pH 2 and pH 1 would also be red. So anything below pH 3 is going to look red. Anything above pH 10 is going to look violet. So why, when I mixed the red and the violet, did it turn green? It's because of this pH scale here. See, when you add acid, which is pH 3, and base, which is pH 10, they neutralize each other. So they're going to neutralize each other. The acid will neutralize the properties of the base will neutralize the properties of the acid, and those will meet together at pH neutral, which is green. That's why we got the green color when we mixed violet and red. That's what's going on there. We're just doing acid-base reactions. What acids and bases I'm using? Trabant, I'm using 20% by weight hydrochloric acid, and 20% by weight sodium hydroxide. I'm not doing any substitution reactions. I don't think so anyway. Make some energy or something glow. So somebody's not understanding what makes the color change. Okay, so here's what's going on to make the color change. There are a mixture of dyes in these flasks. I'm going to talk about one of them, all right? We're just going to talk about one of the dyes. One of the dyes is named phenolphthalein. It's actually the one that's a laxative. And phenolphthalein, thank you there, Jaguar. Phenolphthalein shows these colors at these pH values. So phenolphthalein adds no color at all of these pH values, but it does turn like a reddish pink at high pH, pH 9 and pH 10. And here's the way at least, phenolphthalein works. I'm just going to talk about this one because it's simple. Phenolphthalein, when it's in an acid, so I'm going to add acid to both of these. The phenolphthalein is going to go colorless when I do that. The other stuff is, doing its thing. But phenolphthalein is a ring-shaped molecule in an acid. And when it's in an acid, there's a lot of protons around. And we're gonna symbolize the protons by this little white plastic piece. And when there's a lot of protons around, phenolphthalein grabs onto that proton, and it makes a ring shape like this. And when phenolphthalein has this structure, the ring-shaped structure, it's colorless. Now, in a base, the protons get taken away by the base. And so these protons are removed by the base. So when there's a lot of base around, the protons get removed. And when that proton gets removed, the phenolphthalein molecule goes boop. The ring pops open. And with that change in chemical structure comes a change in color from colorless to colored. And there's actually 4 different compounds that I have in the universal indicator. And all 4 of those different compounds undergo different, they have different structures, so they have different colors, and they undergo different transformations with the pH. That's how it happens. Oh, someone says this doesn't matter in life. Absolutely, actually it does, see? Because pH is very important in the body. The pH of your blood is regulated very tightly at pH 7.4. And if it varies too far from that, for example, if it drops below pH 3, you die. So very literally, the experiments I'm doing are related to a concept that is involved in keeping you alive. Put your finger in the tornado. Very nice. Very nice. You can hear my dog barking maybe. Here we go. Let's add a little bit of acid here. A little bit of base I'm going to add to the one here on the right. I really like this small stir bar. You get some very interesting flow patterns going on. How does the body tell what your pH is? What an interesting question. Well, I tell you what, you can certainly tell when, for example, your blood pH is getting high. If you have ever hyperventilated, that is often caused by your blood becoming a little bit too alkaline. And what happens is you start to try to breathe a little more to try to get rid of the extra carbon dioxide in your blood that's making the pH, you're trying to actually inhale a bit more to get rid of that high basicity. Thank you there, Skull Crash. If the pH is under 3, does it change color? Buzz, it remains red at pH 3 and below. Thank you there, Adonis. Make a complete chemistry course. Kazi, I have a complete chemistry course. If you will go to my secondary channel, it's called Tommy Technetium Teaching. You'll see 2 courses outlined there. One of them is General Chemistry 1, and the other one is General Chemistry 2. So I have an entire chemistry course online. I filmed it during the pandemic. So if we have low pH in blood, what happens? Samuel, you die. You may have heard of diabetic ketoacidosis. That's what happens when diabetics, type 1 diabetics, they can't get glucose into their cells and their body starts to break down protein. And when that happens, they start to generate a lot of acid in the blood. And when that happens, there can be some real trouble. If your pH, if it drops too low, man, it can be lights out. Samuel, I hope your cousin was okay. Because I think the statistics are that roughly 1% of people who get diabetic ketoacidosis die. It's very dangerous. Sorry to hear, Samuel. Thank you there, Skull Crash. I appreciate that. Thank you there, Leaf. What is the most acidic pH that a human can consume without harm? What a great question. I would imagine that, the pH in your stomach is like pH 1, or I would say when it's really acid, it's like pH 1. And, this is going to get a little gross, so I apologize. This is a fair warning. I'm going to talk about something that's a little gross. But, if the pH of your stomach contents is 1, when you vomit, of course, the stomach contents come back up out of your body, and it coats your, esophagus, and that doesn't kill anybody. So I think from that fact, we can at least say that you can have something with a pH of 1 go down your throat and into your esophagus. Since it's coming out and it doesn't kill you, it can go down and it won't kill you. So I would say at least pH 1, and maybe even lower. Is that why? Yes, Manny, that's exactly why it burns when you vomit. That's exactly right. How does acid in your stomach not burn you? Great question, Skull Crash. It's because your stomach has cells in it that not only make stomach acid, but it also makes mucus that coats the cells in your stomach, and that mucus protects your stomach from being burned by it. Okay, here we go. Let's add a little bit of acid to both sides. Got a little bit of stoplight going on. What are the acids and bases I'm adding? I'm adding 20% by weight hydrochloric acid and 20% by weight sodium hydroxide. Thank you there, Plague. Max, not going to happen. One of the dyes that's in here is a laxative. Look at the beautiful flow patterns that are happening over there on the right. There are indeed a lot of colors. It's gorgeous. Let's add a drop of base to both sides. See if you can figure out what's going on to the pH as I add a drop of base. Is it possible to eat certain foods to create more mucus in our stomach? Samuel, I don't know. Do we have any biologists in the chat that can help answer that question? Are there certain foods that help us create more mucus? I do not know, but it's a great question. What happens when your blood gets too basic? Darkois, I'm sorry. If your blood pH gets too high, it can kill you, just like your blood pH getting too low. Yeah, I get that a lot. People say I sound like Peter Griffin. I hear that a lot. I am a Midwestern guy. Maybe that's got something to do with it, eh? Have I ever tried to extract hydronium or hydroxide? I've not. That sounds interesting. Face wash and soaps, they try to adjust the pH up a bit. That's correct. Samuel, we here in the United States use alkaline and base synonymously. So alkaline would be the opposite of acid. I don't know what a Peter Griffin laugh sounds like. I don't watch the show that much, so I can't help you out there. Yeah, I mean, it's safe to touch it, but I'm not gonna mess with that. Hey, Brantley, what's going on? Come on now. Drop me a test tube emoji in the chat, because we're doing some chemistry, baby. Can you taste test pure potassium metal? I wouldn't do it. I would not do it. What's my favorite acid? What a great question. What is my favorite acid? I would probably say hydrochloric acid, good old stomach acid. Come on there, Leaf. Thanks there, bud. Thank you there, Kazi. I appreciate that. How you doing there, B? Good to see you. Thank you there, Olive and Cyan and Kazi. Appreciate all the test tubes. So how does different water have different pHs? So absolutely purified water would have a pH 7, but almost no water is perfectly purified. Thank you there, Lee. Thank you there, Icky75. Thank you there, Leaf and Omar. Most water has a little bit of carbon dioxide dissolved into it, which makes it slightly acidic. And then people will add minerals to water, and that usually will increase the pH a little bit. What makes it spin? This little thing here is like a fan on the inside. There's magnetic fan blades that spin. And then inside the flask, I have a little magnet. It's a little magnetic stir bar. And as the magnet fan spin, it makes this spin. Pills at the bottom. That's the way I should have said it, Sam. Much quicker. Omar, come on, baby. Omar, dropping $1.99 for me. Appreciate that. I love it too, Brantley. Thank you for the $1. I love it. That helps me buy my materials. So I appreciate that. What's the best water for rehydration? Just drink any old water. Tap water's fine as long as it's, healthy, safe. As long as it's been tested and there's not a bunch of junk in there. Guadalupe, I'm so sorry. I hope I got you. The comments are coming through pretty fast, so y'all going to have to forgive me that I can't quite get through and read them all. Thank you there, Ari. Purified water is not so good. Yeah, most people don't like water they don't like the taste of it, of water that's been highly purified. It has like a sharp taste to it. Why does it change color from the bottom and not the top? Great question. So here's what goes on here. There's a vortex here, right? There's a vortex here. And watch what happens. I'm going to add acid, which is going to make this turn redder. I'm going to add it to the center of the vortex. So notice, you see that the red color remains in the vortex. I'll do it over here too. It's harder to see the vortex here unless I add the acid. Notice when I add the acid to the center of the vortex, it tends to stay in the vortex, okay? And that's because the center of the vortex is low pressure. Just like the eye of a hurricane is low pressure, the center of the vortex is a low pressure. And material moves from high pressure to low pressure. So if the material's in the low pressure region, it's going to tend to stay there. And it stays there until it hits the bottom. And then when it hits the bottom, it gets pushed out by the stir bar. And that's when you see the color change at the bottom. So that's why you see that color change at the bottom. It's kind of cool, huh? Beautiful patterns. Absolutely beautiful patterns. What would happen if you drank it? Tanya, the live would end in about 10 or 15 minutes because one of the dyes in here is a laxative. So I'm not going to drink it. Thank you there, Danny. Yeah, I'm a teacher. Algeron. I am a teacher. Thank you there, Sonic. So high pressure to low pressure, Samuel. Yep, you got it. You can see the effect. That's why they call circling water under waterfalls a death zone. Interesting. I love it too, Ari. What do bases taste like? Omar, they taste soapy. They tend to taste soapy. What happens when you add one more of each in the bottles? I'm not quite sure I understood that. I apologize. Samuel, thank you for the comment. Hello there, Kevin. Hello there, Vivian. Hello there, Dave. I'm at a school in the Midwest. Keep us up, man. Hey, thanks, AS7Zen. Appreciate it. Acids tend to taste sour, Omar. Acids tend to taste sour. What happens if you make the magnet stop turn? Well, let's find out, Leaf. Let's find out. We're going to turn these off here. Let me get this one over here first. Let's get this one nice and basic over here on the left. And let's make this one over here on the right nice and acidic. All right. And then we're going to turn the stir bars off. Why is glass the best container, Kazi? I apologize. I've seen that question a lot. I'm not real sure what you're asking there, so I apologize. I haven't answered the question, but I don't really know why you're asking why glass is the best container. Come on, Danny did some chromatography lab work today. Let's go. Is that research or was it just like a teaching lab? Okay, here we go. So we've turned the stirs off. I'm going to add some base over here on this side. Let's go like 1, 2, 3, 4 drops. And let's add some acid over on this side. We're going to go 1, 2, 3, 4, 5, 6 drops. And let's just watch what happens. Thank you there, Ryan. I appreciate it. What's my favorite color of acid? Interesting. Probably I like the red color. What's the most acidic a liquid has ever been? Omar, look up fluoroantimonic acid. I think that's the most acidic thing that there is. It is cool, Leaf. I agree. It is kind of neat. Ari, I teach at a university. I used to teach 7th grade. Thank you there, Plague. I appreciate that. Thank you there, Red. Come on. We got some people who are giving me some subs. I appreciate that. I'm trying to hit 500,000 subscribers, and we're getting really close. I think I'm like 490 or something like that. So, yeah, consider subscribing if you like this kind of thing, if you like science, if you like goofy science experiments. I love doing them. I do have a degree in chemistry. You're local. I have a PhD in chemistry and a master's degree in chemistry. Somebody, Soy the Best, asking about Gallon Stand. Come on, I love doing experiments with Gallon Stand. Yeah, I mean, Tanya, I do some of these experiments in college. I agree, Roselle. How much money do I make on YouTube? Let's put it this way. I'm not quitting my day job anytime soon. Not even close. Not even close. Was it hard to get my degree? You're local? Yes and no. Well, what in the world do I mean by that? Of course it was hard. I mean, anything that is worth doing is going to be difficult. However, I got to tell you, man, I loved it. I absolutely love learning. I always have. And if you're a type of person that loves to learn, getting a degree is a joy. It really is. And it doesn't mean it's not easy. It doesn't mean it's easy. Things can be hard and enjoyable at the same time. And that's just the way that I found graduate school. You want a PhD in physics? I have, Arf. I've made elephant toothpaste. Come on, baby. Let's get some PhDs in physics. Keep firing away. Hey, Fire Chi, I'm assuming that your comment, and I apologize that I haven't been calling out your comment here. I've seen it a lot, and I apologize for not saying anything there, Ari. I'm assuming by your comment you mean that you enjoy pH 7 and pH 8. Look at this gorgeous pH gradient we got going on over here. I mean, that is just beautiful. We got the rainbow going on, and I love it. I agree, Samuel. It's looking beautiful. Hello there, Kimberly. Hello there, dang JOS. I agree, Kimberly. It's very beautiful. Very, very pretty. I'm loving it. I love when I get something like that. Thank you there, Kuro. The base stronger? Yes. Z. The base does tend to be slightly more concentrated than the acid. I'm noticing that as well. Good observations. How'd I get the perfect rainbow? I don't know, man. Just sometimes it shows up, Kazi, I'm loving the comment. Hello there, Didu. It is beautiful, Spider. I agree. Totally agree. It's absolutely beautiful. It's stunning. It's about making... Yeah, I mean, that's what we're doing, right? We're just making some beautiful colors, and we're talking about the science behind it, and just enjoying each other's companies. Life's preppy. How does it work? Asked Kimberly. So here's how it works. In these flasks, and while you got to forgive me, when I go into long explanations, it's hard for me to read comments. So how this works is, in both flasks, I have added this stuff. It's called Universal Indicator. It's also known as Rainbow Indicator. And what it does is a mixture of chemicals that shows different colors at different pH values. So you can see, if it's pH 3 like it is up here, it's going to be red. If it's pH 10 like it is down here, it's going to be violet. All right? And if you look over here, this is pH 6. Now watch what happens when I add base to this at pH 6. In goes the base, or alkali. It shifts to a green color. The pH went up when I added base. Let me add another drop of base. I don't have any gallon stand with me, Soy. I apologize. There's another drop of base. And the withered ones, I'm coming your way. There it is. We got some purple. We got some purple. Nice. So we can see as I add base, the pH goes up. Now to this one over here, I'm going to add acid. Yes, that's right, dang job. JOS, there's a drop of acid. The base is sodium hydroxide. Nice, Danny. So you notice when I added a drop of acid, the pH went from 10 to 7. It went down. I'm going to add another drop of acid. And the pH went from 7 down to 6. I'm going to add another drop. And we went from, well, that's 6 now. Okay, it went from 7.5 or 6.5 to 6. I'll add 2 drops of acid. And we're down to orange. All right, Leaf says turn the magnet all the way up. Let me try to balance this first. So usually when I turn the magnet all the way up, here we go. I'm turning up the speed over here. You'll notice the vortex starts getting bigger. Let's see if we can get it all the way without the stir bar falling out of orbit. Come on, baby. I'm about... Oh, there it goes. It just knocks it out of orbit. I can't get it going all the way. No, the glass does not react with the acid or base. There is an acid that glass will react with. It's hydrofluoric acid, but I'm not adding that acid to either, so we're okay. So on this flask, the reason why we're seeing a rainbow is because the mixture is not being homogenized with the stir bar. And so when that happens, it takes a while for diffusion to happen. It happens a lot slower than most people think. And so there's a bunch of acid here that's trying to diffuse down, and there's a bunch of base here that's trying to diffuse up, and where they meet in the middle, it's going to be neutral. So you can just see the pH gradients like 3, 4, 5, 6, 7, 8, 9, 10. Isn't that cool? I'll start spinning this over here. So over here I'm going to spin, and that's going to start to homogenize this. If there's more acid than base over here, it's going to be red, orange, or yellow. If there's more base than acid, it'll be blue or violet. And if it's perfectly balanced, it'll end up green. Let's see where it ends up. So long, Kimberly. Thanks for hanging out. Hello there, Pinky. It looks like they were fairly well balanced. We ended up at pH 7 or so. Bye-bye, Rainbow. We're going to try to get it again, though. Good night, kitten. We're going to try to get the rainbow again. So I'm going to add a bunch of base. So add a bunch of base here. Get the base going. And we're going to add a bunch of acid over here to get the acid going. And then we're going to turn the spinner off. Okay, we're going to turn the spinner off on both sides. And on this side, I'm going to add, let's go like 4 drops of acid. Well, I'll do this side first. We're going to add like 4 drops of base. 1, 2, 3, 4. And then over here on this side, I'm going to add like 6 drops of acid. 1, 2, 3, 4, 5, 6. Let's see what happens. Let's just see what happens. When it comes to plants and water, how can you change water's pH? You just add minerals. Just adding minerals to put a Scrub Daddy. Come on, Cyan. You've been watching some of my Scrub Daddy videos. Yeah, you just change the pH of water by adding minerals to it. That's all you got to do. The fact that such little base brings us to 10 shows the logarithmic scale of pH. Indeed, it does look cool, Spider. I agree. We got a lot of interesting stuff going on. What is the best pH? I don't know, Samuel. I have no idea. Hello there, Bella. Hello there, Daisy. Thank you there, Samuel. Nice. Thank you there, Cyan. Thank you there, Leaf. Appreciate it. What if I put food in there? Bella asks, what's happening? Man, some of these folks in the comments are just crazy, man. Oh. How's a pH chemical work? How do I know when it changed color so many times? Hey, thanks there, Talon. Thank you there, Bella. So here's how it works. So let's talk about the whole thing. So in each flask, I have a mixture of chemicals called rainbow indicators, all right? And rainbow indicator or universal indicator, it contains these chemicals: thymol blue, methyl red, bromothymol blue, and phenolphthalein. And at pH 2, for example, thymol blue is red, methyl red is red, bromothymol blue is yellow, and phenolphthalein is colorless. And if you add all those colors up together, thank you there, Talon, they look red. At pH 7, you get a dark green with bromothymol blue, colorless with phenolphthalein, yellow with thymol blue and methyl red, and you add those up together, and it gets like a very slightly yellow-green color at pH 7. The violet color you see over here, that's because in that pH, blue for thymol blue, yellow for methyl red, blue for bromothymol blue, you get a dark red for phenolphthalein, you add all that up together, you get purple. That's how it works. Add bromothymol blue in a plant. That'd be kind of fun. Put sparkling water. Well, let's do it. Let's do sparkling water. Hold on a second. I'm going to go get some for you. Give me just one quick second. Oh, okay. So I don't have actual sparkling water, but I do have some Sprite. So we can check the pH of some Sprite. Let's do that, okay? I've been telling you all night long that soda has a low pH. Well, let's see if what I'm telling you is true or not, okay? So I'm going to take this flask here. I'm going to open up. You're welcome, Lawar. I love it when people ask me to do certain experiments that I can do. So here I'm going to add a little bit of Sprite to this. Well, it sounds delicious, doesn't it? Sound like a commercial almost. Okay. Hey, let's drop a stir bar in there, shall we? Let's just stick one in there. We're just for the heck of it. All right? Put a little stir bar in there, a little baby one. Look at that. Let's get that little guy going. Woo! All right. Now I'm going to add some universal indicator. How you doing there, struggling? Nice to have you along. Okay, in goes the universal indicator, which is going to turn, well, you can see it's green, right? You can sure see it's green. In goes the universal indicator, and of course it turns red because Sprite is acidic. Isn't that beautiful? Come on, that's pretty. I don't know. I love science, but I certainly love the beauty of science. It just looks pretty to me. No, this is just Sprite. That's all it is. Okay, now what I'm going to do is I'm going to try to neutralize the Sprite. Let's do that. So I'm going to start adding base. I'm going to add drops of base here. Boop, there's one drop. Oh, man, how much base is it going to take to neutralize the acid in the Sprite? Let's find out. There's 2 drops of base. There's 3 drops of base. There's 4 drops of base. I just used water before this. 5, 6, 7 drops of base. Have you noticed the color shift? Have you noticed the color shift? So we've gone from like pH, where's my pH scale? Come on, baby, where are you? We've gone from like pH 3 to pH 4 or so, right? Because I'm adding base. Here we go. Add another drop of base. That's kind of fun, man. We're doing a titration. I forgot how many drops I've added. Hey, look at that. We're at pH 6. Come on, man. Here we go. Let's add another drop. Have we neutralized the acid in Sprite yet? By the way, there's 2 acids in Sprite. One of them is just the carbon dioxide itself. When carbon dioxide dissolves in water, it makes it acidic. The other acid that's in the Sprite is citric acid. That's added. Titration, Tamaki. Sorry there. Thank you there, struggling. Come on, we're trying to get this to green. I want to get it to neutral, although it might be buffered in a way. Buffered means resist changes in pH. So we're in a buffered system right now. You can see I'm adding a lot of base. And as I add a lot of the base, the pH isn't changing much. I mean, I've added a bunch of drops of base, and we've pretty much stayed at pH 6. Random thinks we're at green. I'm not thinking we're there yet, Random. I'm going to keep going. Horror stories of titration. I'm loving it. No, it ain't going to explode. Let's add like 1, 2, 3 drops. Come on, let's go green. There it is. There it is. I think I've got, well, maybe not. Maybe not. Yeah, local, I have done the BZ reaction. Great stuff, man. I'm loving the BZ stuff. I've got some videos on it if you want to check it out. There we go. Boom, boom. Let's do 2 more drops so we can get to green. Is it okay to eat now? I wouldn't eat it now. That's because one of the dyes in here is a laxative. So it did go back. So I want to talk to you about why it went back. Great observation. You'll notice it was a nice green, and then it slowly faded back to yellow. The reason why is because there's still carbon dioxide dissolved in here that's acidic, and the reaction between carbon dioxide and the base that I'm adding is slow. So here, I'm going to add another drop. That should turn green. And the base has been added, so we've gone up to pH 7. However, there's a reaction between the dissolved carbon dioxide that's still in here and the base that takes a little bit of time. And you can see it's fading back to yellow. Isn't that kind of cool? I mean, the green tint is kind of surviving. I'm going to add another drop here just for the heck of it. And let's get this one going, man. This one didn't turn out quite the way I wanted it to. Well, let's see if we can get that pH gradient going again. I'm going to add like 3 drops, maybe 4. See what happens over here. You can see the red color growing in. Hello there, Epic. 24 drops, says Awar. You got it. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's enough. I made it almost there. Thank you there, Fat Dog. I appreciate that. How you doing there, Random? Nice. Dang. The chemist has entered the chat. Hello there, Jessica. Yeah, isn't that cool? We got some goofiness going on over here on the right, man. 34 drops at the end. Thank you there, Jessica. I appreciate it. Thank you there, Kazi. You drink purple Sprite? I wouldn't want to be drinking that purple Sprite. That's not for me. You want to do another titration of Sprite? Give me a thumbs up if you want to do another titration of Sprite over there on the left. Give me a thumbs down if you're like, nope, don't want to do that. Hey, Firekeeper, we're just doing some science experiments over here on this stream. That's what we do. Enjoy each other's company, do little science experiments. Are there a limit to what compounds pH can be like carbon dioxide? Is the more acidic CO2 or less, for example? Yes, different compounds have different degrees of acidity or basicity. Mr. Yeast, come on, baby. Come on, Mr. Yeast. Whoa, 20 drops on the right. You got it. You got it, Mr. Yeast. He says 20 drops on the right. That's what I'm doing. They gave me $1.09. Well, no, I'm sorry. Pound. 1.99 pound. Loving it. Okay, so they want 24 drops on the right. You got it. I'm going to stir it up first. And Mr. Yeast, do you want me to add acid or do you want me to add base to this side? 24 drops. Thank you there, Herbo Soy. Crystal Pepsi, that would be fun to do. My son asked if you drank all on the left. No way. Acid, you got it. All right, 24 drops of acid for Mr. Yeast. Here we go. Let's count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And just for the heck of it, we're going to chase it with 12 drops of base. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 for Mr. Yeast. Come on, baby. Come on, baby. Pretty. What's acid and base? Crazy cow. An acid is a substance that donates what we chemists call protons to a solution. A base is a substance that takes protons away from the solution. You're welcome. Thank you, Mr. Yeast. That was a lot of fun. That was a lot of fun. Good times. How is it changing colors that fast? Ray Lynn, what's going on in the solution is I have a mixture of molecules, dye molecules, that change color depending upon pH. pH is just how acidic or basic something is. This stuff is highly acidic. Notice the colors that are acidic, yellow, orange, or red. So I'm going to add something that's highly acidic to this. In it goes, and of course, you're going to see a red color develop fairly quickly because I'm adding something that's highly acidic. On the other hand, if I add something that's basic, that's this stuff, that changes the colors to aqua, violet, or blue. So if I add base to this side, you can sort of see the drops of violet cascading down as it's changing the dyes to the violet form. That's what's going on there. Is gold extract a base? In my understanding, gold is a metal. In metallic form, it's neither acid nor base. Can you explain titration, Max Who? Hey, good night there, Kazi. Does the universal indicator show the color of the stuff? No, the universal indicator itself changes color. So universal indicator is a mixture. You can think of it as just a bunch of dyes with different color. What's interesting about the universal indicator is it changes color depending upon how acidic or basic the environment is. Make it spiral. You want to spin this one up, or you kind of want to leave this? Here, we'll do this over here on this side. And let's do a titration. Somebody is asking, come on, man, let's do a titration. So here we're gonna do a titration over here on this side. So let's do a titration. And what I'm going to do for the titration is first we're going to add a bunch of acid over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so there's a bunch of acid over here. And now I'm going to titrate the acid. So we're going to try to figure out how much base it takes to neutralize the acid. All right? So here we go. I'm going to add 1 drop of base. In it goes. And we ask ourselves, have we neutralized the acid? No, the pH is still 3, so I'm going to add another drop of base. And in a titration, we do this a lot more carefully. I would try to very carefully measure the amount of base that I'm adding. I've added 2 drops. I've added 3 drops. I've added 4 drops. 5 drops. This is kind of looking like the Arizona flag over here. 6 drops, 7 drops. Oh, we're getting close. I can tell a little color change. 8 drops. Thank you there, Skull Crash. I forgot where I'm at. What am I at? 9 drops? I totally forgot. I forgot, but we're really close to neutral here. So probably the next drop, it's going to change to basic. And actually, it's not. Ooh, we're almost at neutral. We're almost at neutral. I'm going to add 1 more drop. And when we get to that green, we are at the end point of the titration. That's how your titration works. And if we would have carefully counted the number of drops or measured the volume of this and known its concentration, we could have figured out how much acid was present. That's what a titration is all about. Oh, but folks were guessing how many drops. Very cool. But could you turn the one orange? All right, Juan. Juan wants some orange. Let's try to. The orange is a little tough to get, but I'm going to go for it, all right? We're going to try to get orange for Juan. Can I try rubbing alcohol? Like the pH of rubbing alcohol? I've got an experiment with some rubbing alcohol. Can I make a buffer here in the next few minutes? Yeah, we can make a buffer. Okay. Oh, we're trying to go for orange. We're trying to go for orange. So here we go. I got an experiment with some isopropyl alcohol for you. Let's do that here in a second. I'm going to try to make this orange, and then we'll do the next experiment. Can I recover the acid and base I used in the titration? Not really, because it turns into salt. So it just goes to dissolve sodium chloride. No, I don't have any dry ice. I don't have any dry ice. I was going to try to get some, and I didn't. Make one green. I'll try to make one green. Man, I'm getting some comments for... Thank you there, S. Slaney. I appreciate it. Thanks for letting me know. How you doing there, John? Man, I'm having trouble getting these colors. I don't think that's gonna... There it is. I got green on the left, baby. Come on now. And we got to get orange on the right. Hello, Hero Brian. There you go, Joe. Hello, Casby. I'm loving some science too, Sandy. Kit Games wants it blue. I'm getting way too many color requests. I can't make it black. I'm doing all right there, John. Thank you there, Furl. Appreciate it. Hey, I think I got the orange. Come on, baby. We got orange. We got some orange. Okay, somebody wanted an experiment with some alcohol, so let's do that. I hope this works. Here we go. Let's put this up here. What's the science behind this? There's a lot of science behind this. Hello there, Samuel. Here we go. So I've got my flask here. All right. Got my flask here. You're going to have to forgive me. All right. I apologize, but I didn't know this when I was making the solution. Never mind. I'll talk about it later. I'll talk about it if somebody mentions it. All right. So I got my flask over here. Here we go. I'm going to add some universal indicator to the flask over here on the left. It is Hero Brian. I am so sorry that, yes, there was a spider that found its way into the bottle, and I didn't check to see if it was clean before I used it here in my basement. So here I'm going to add a little bit of universal indicator. It was already dead, though. I know that. So I'm adding some universal indicator. I'm so sorry, y'all. I'm so sorry. And it goes. Oh, crap. I knew somebody was going to see it. Oh, gosh. Thank you there, John. So, yeah, isn't that kind of cool? Is the web trapping it? What a great question. Is the web trapping it? No, there's actually two different liquids in here. There's alcohol, that's this layer here on top, and there's salt water. That's this layer here on bottom. All right? So what I'm going to do now is I'm going to add, and what I just added is universal indicator. So this is kind of fun. I'm going to add a crap ton of base to this, okay? So we're going to add a bunch of base. Just a bunch of base. Look at that gorgeousness. That looks kind of cool, right? You can tell the base is more dense than the the alcohol, because it's sunk, and it's turned everything blue, right? But it didn't sink down into the salt water real well. I'm gonna, Kevin. Kevin says shake it. That's exactly what we're gonna do. Should we? Oh, God. Oh, no. Here we go. And I'm gonna shake this up, and let's see what happens. Here we go. Oh, my goodness. Now, that makes sense it turned violet, right? Because I added a bunch of base. I added a whole bunch of base, right? So we know that if I add base, everything should shift to a blue or violet color. But just watch for a bit. Just watch what happens over here. Let's see if it'll separate. Do you think it's... What's going on? Let's turn this off. It's making a bunch of noise. Can you see what's happening? Can you see there's something going on here? It is re-separating, isn't it? Like it was, before. Remember, there was alcohol on top and there was salt water on the bottom. I'm getting there, Shark Boy. You hang in there. It's coming. I'm telling you. So remember what we did, just to recap. In this bottle was a mixture of salt water and alcohol. The alcohol was on the top layer. The salt water was on the bottom. Okay? Let's get this off and let's just focus on this one right here because this is where the action is. And I'll move in a little closer. There we go. We'll move this down just a bit so you can kind of see. I'm noticing 3 different colors. Yeah? You see down here at the bottom, the saltwater layer, that's kind of like a purplish violet color. Up here at the top, it's a little more darker blue, and here in the middle, it looks a little more purple, like blue purple. So what's happening is the alcohol is separating from the salt water. So up here is your your alcohol, down here is the salt water, and in the middle is a mixture of the two. And it turns out, you might remember I told you Universal Indicator has a bunch of different dyes in it. And it turns out that phenolphthalein, the one that kind of turns this color, it dissolves better in the saltwater layer. And all the other compounds dissolve better in the alcohol layer. And that's why you're seeing this separation of colors. Kind of cool, huh? At the end, it should separate into 2 different phases. One of them is going to be up at the top, and it'll be blue. The one at the bottom will be violet. And that's what we're seeing, isn't it? And since I'm getting bored of waiting for this, I'm going to add acid to this and shake it up and see what happens, just for the heck of it, okay? Here we go. Thank you there, Puffy. I appreciate the subscription. We're trying to get to 500,000 followers, so consider, sharing the channel with others who like science. In goes the acid. In goes the acid. You can definitely see the acid sort of collecting here, right? Oh, look at that. Isn't that gorgeous? Does that make sense that I added acid and it turned the indicator red? Sure it is. Sure it is. I have a question about this one. I have to ask myself, is it worth the time? I'm sorry, I don't know what the question was. Okay, Lincoln, come on, baby. How much money is the spiny thing and what it called? Lincoln, I apologize. I don't know what you're asking there. The spiny thing. I apologize. I don't understand the question. Thank you there, Gojo. What is it called when, Lincoln? What's it called when what? Oh, the spinny thing. Got it. What's the spinny thing called? Okay, I'll talk about that, Jeremy. Let me shake this up a bit. Of course, it's going to change to an acidic color. So the spinny thing is just a magnetic stirrer. I'm not selling these. It's just, you can Google this online, magnetic stirrer. This one here I bought. I just put a white thing on it to make it look a little better. This thing I bought for $40. All right? Magnetic stirrer, Intel Lab. And if I got it for $40 online, and it came with a magnetic stir bar. So you get not only the spinner, the stir bar, but you get you not only get the, the stir, but you get the stir bar as well. Kind of cool to see it work like that, isn't it? All right? You're welcome. You're welcome there, Lincoln. So there you go. And you can see this one separating out too. All right, I'm going to warn you here at the end of the live. What I normally do is I stop doing experiments and I flip the screen around so you can look at my ugly mug. I'm going to warn you right now, I'm a 56-year-old man in his basement doing science experiments. So if that's not something you want to see, it's time to get the heck out of the live now. Just fair warning, okay? I'm loving some science too, Puffy. And I just talk to folks. I just talk to folks at the end of the live, okay? So I'm going to give you a chance to, take off if that's not your cup of tea. I'll leave that separate. We'll put this on here. Look, they're both orange. They're both kind of orange in color here at the end. All right, we're going to flip it around. I'll talk to folks, and we're going to call it a day. Here we go. All right, flipping it around. I got these on. They got readers in them so I can see what the heck is going on. Puffy, that'd be fun. I'll see if I can't get that. Thank you there, Awar. Thank you there, Puffy. Thank you there, dang JOS. Thank you there, Sandy. Thank you there, John. Appreciate it. Thank you there, JD. I'm loving it. Oh, I'm doing all right, Alexa. Thank you there, Puffy. I look like John Cena. Yeah, I was a wrestler back in the day. You see that? See that little ear going on over there? This is our badge of honor if you're a wrestler for sure. Thank you there, Jacqueline. I'm loving the shirt too, man. I love this shirt. I got a bunch of them. Yeah, you can. You can see the experiment still in the reflection, which is kind of cool. Very cool. I usually stream at this time on Friday, so this is usually the time I go. Thank you there, Twiggy. Well, here, let's take the glasses off, okay? I don't look quite so cool with the glasses off, so, you can see the old man in the eyes if the glasses are off. You can tell. So let's just stick them back on, shall we? Oh, nice. Hey, greetings there from Russia. I'm loving it. Hey there, Tanya. Thank you there, Abdullah. Where's Tin on my shirt? I don't know, but you know what? You know what is on my shirt? Come on, baby. Come on, baby. Technetium is on the shirt. I'll have to look for Tin and see if I can find it. Thanks there, baseball lover. Hey, you've been watching the Yankees and the Guardians. What a great game that was last night. Thank you there, Tanya. Thank you there, Jacqueline. Hello there, family. I don't see Tin either. I don't see it either. Here, let's see. It's on. I can't see, obviously, the back, but you can tell me if you see Tin on the back, all right? Is it on the side there? Can you see it on the back anywhere? I don't know. Can you see it? Turn around this way. I don't know if there's Tin on there anywhere. I forgot to shave. I know. I always have trouble shaving. Oh, thank you there, Yash. The right sleeve, huh? Well, I don't know which the camera is showing. I guess for me, this is the right. Palladium, I don't know. There's a bunch of different elements on there. Thank you there, Sandy. Tennessee. We got any folks from Tennessee out there? Thank you there, Puffy. Hey, I want you to drop in the chat the symbol for your favorite element. Let me see a couple of your, got a couple golds. Hello there, Ergies. Someone from Colorado. Someone from Kentucky. Someone from Virginia. There's someone from Tennessee. Oxygen, copper. Someone from the USA. Someone doesn't know their favorite. There's some from Tennessee. Someone just learned their first 20 elements. Take the glasses and hat off. There you go. That's what it looks like with the glasses and hat off. Utah. It's hard for me to read without the glasses, though. I'm an old dude, so I need the readers. Tennessee, America. Cerium. Thank you there, sports. Hello from Paris. That's interesting, man. Tungsten. Calcium, osmium, scandium, helium. Someone from Brazil. Pennsylvania. That's where I went to college. Germany in the house. Nice. My ancestry is mostly German. Somebody said I missed it, but somebody said they just had to memorize the first 20 elements. That's awesome. South Carolina. Lots of South Carolina folks. So long, Gojo. Legends, South Carolina. That's cool. Hey, it's fun hanging out with you all tonight. It really was. Really had a good time. Ukrainians studying in France. That always amazes me. People who are from one country and study in another, major props, man. That's really cool that you can do that. Thank you there, Connie. Tanya, come on now. Appreciate that, Tanya, telling me I'm our favorite YouTuber. I appreciate that. Thank you so much. Hello from the Middle East. That's cool. That's so cool. Someone from England. Someone loves you, 235. I won't be streaming tomorrow, Puffy. I got to keep my mental health, man. Someone's a chemistry major on their way to being a biochemist. I love it, Twiggy. Come on now. Plastic surgeon in the U.S. Awesome. Thanks for the work you do. Bobby, I have not done a butane bottle rocket, but I've done a liquid nitrogen bottle rocket, and that is awesome. Hey, Nick Gamer, come on, man. Come on, man. Give me $10. I appreciate that. Not necessary, but my gosh, very, very much appreciated. Thank you. Why does everything decay into lead? I'm going to have to go back and read my general chemistry book to remember that. It's just fairly stable, right? Someone from Puerto Rico, but speaks English. Very cool. Nursing majors. Thank you there, Tanya. It's very nice of you. It's really nice. Thank you so much. Yeah, I need a video. I do all my editing. I do all the writing. I do all the concept development. I do all the producing. I do everything, man. Editing, writing. I do the speaking. Yeah, I do it all. Oh, someone's a physics major. I'm loving it. Twiggy, I got some Leidenfrost experiments in... I got some Leidenfrost experiments in the works. Aw, Dreadnought. Come on, that's really nice. That's really nice. Really nice. Well, all right, folks. I'm running out of steam. I'm running out of steam. I think I need to turn it off for the day. All right, I gotta turn it off. So thank you all for being here with me and for enjoying some of the beauty of science that we saw. They were seeing the end result of some experiments I did. Thank you for hanging out with me tonight. I will, Dreadnought. I hope you take care too. So long, Tanya, and y'all spend some time. Get outdoors, look at the clouds, look at the streams, listen to the birds, check out the sky and the star and the comet. I don't know if you've been checking out the comet that you can see lately. You know, the beauty of science, it's all around us. It's just so beautiful and gorgeous and artistic. So spend some time checking it out. Thanks for being here with me. I love you all, and we'll see